This is a flow meter for liquids and gases. It's based on the Fluidistor principle and has no moving parts. The principle is simple. If a gas or liquid is discharged from a port and then flows further along a wall, the flow will give rise to a low pressure area along the wall, and the jet of fluid will be deflected toward the wall. If another wall is provided on the opposite side and at the same distance from the port, balance will be established, and the jet will flow in parallel with the walls after leaving the port. But if a port is opened in the left wall, the pressure along the right wall will be lower than that along the left wall. If a port is now provided on the right wall too, balance will be re-established. If the ports are fitted with valves, the jet of fluid can be induced to flow either along the left wall or the right wall. Opening and closing the valves at a definite rate will cause the jet to oscillate at the same rate from one side to the other. The pressure differentials that deflect the jet of fluid can also be created by interconnection of the two ports. We can also provide a wedge, known as a splitter, in the path of the incoming jet of fluid. We've now produced a Fluidistor oscillator. When the flowing medium enters the meter, it must choose its path to the right or to the left of the splitter, since the center path would be unstable. The pressure at the wall along which the jet of fluid flows will then be lower than that at the opposite wall. Because of this pressure unbalance, some fluid from the higher pressure side will flow through the interconnecting passage to the opposite side. This flow of fluid is known as the control flow. The lower pressure side is thus moved to the opposite side, and the main jet of fluid will also move to that side. The situation is therefore reversed. The control flow has reversed to balance out the pressure differential, and the main jet of fluid will move to the other side. So a cycle or a pulse has been completed. The frequency of oscillation is proportional to the velocity of flow. Every pulse represents a specific volume of fluid flowing through the meter. Since the Fluidistor consists of fluid passages and has no moving parts, there's nothing that can sustain wear, and the meter is always accurate. A chamber located downstream of the splitter contains a lightweight hollow ball which is free to move between two positions. When the main jet flows to the left of the chamber, the ball is displaced toward the right, and vice versa, at the same rate as the switching of the main jet from one side of the splitter to the other. We can count the pulses by electronically sensing the movements of the ball. Every time it changes position, the ball breaks an inductive field and an instrument records a pulse. This system is used for liquids. To measure gas flows, the pulse is provided by a thermal sensor in the interconnecting passage. Every control flow pulse through the interconnecting passage cools the sensor, and this is recorded as a pulse. The Fluidistor measures a partial flow which is proportional to the total flow. We obtain the partial flow by arranging a restriction in the main flow path, thus diverting part of the fluid through the Fluidistor. The sensing head can easily be opened to reveal the ingenious Fluidistor oscillator, which has no moving parts whatever. The ball, which senses the pressure changes in the fluid passages and which applies the electronic pulses, is located outside the Fluidistor itself. The electronic pulses can then be converted into a pulsed or analog output in a signal converter. Fluid Inventor has developed a complete range of signal converters, which are also available in explosion-proof enclosures for hazardous environments. The converted signals are applied to a recorder, computer, direct reading instrument, etc., but can also be employed for direct control of valves and for use in control systems. A simple principle has been ingeniously developed into an accurate and sturdy flow meter for liquids and gases.